Okay, so my name is Masao Fujinara. I'm at the University of Alberta. Not the site lead, as Jana said, but analyst. I'm the one most likely to answer your questions if you send questions to Compute Canada, or one of the analysts. And at the bottom of this slide, there's a link to the slides themselves. So that's at the WestGrid website, the page for this talk. You can get it there. I also have it on Cedar as well, so you can get it from there. So we'll just start presentation. So today we'll be logging into Cedar, which is one of the new machines at Compute Canada. Now this is a typical cluster system, which means that you are working at your desktop and you will be logging into a head node. And from there, you will be submitting jobs to the compute nodes. And there's also a shared file system that connects everything. So everything that you do will be, well, almost everything will be batch-oriented, which means that you have to make up a script for a job. And these jobs are then submitted, and they're queued. And they wait in line until there are resources available to run that job. And the priority depends on your allocation and your past usage. There will be talks more explaining about priorities and allocations later on in the series given by Kamil Marcinkowski. So I won't get into too much detail, but today we're just going to do an introduction just to get you started. Basically how to submit jobs and so forth. So the Cedar cluster is a rather complex cluster. It has all these kinds of different nodes. So some nodes, or most nodes, I guess, have 128 gigabytes in memory. Then there are some nodes with 256 gigabytes, 512 and 1.5, and even 3 terabyte memory nodes. Most of them have 32 cores per node. The GPU nodes have only 24. However, they have GPUs instead. So when you submit a job, you have to know what's available in terms of resources, and so you will have to ask for resources accordingly so that it gets to the right machine that you're intending your job to run on. Okay, the first step is how to connect. On Windows, you can install a program called MobileXterm, which is the recommended software to use because it's also self-contained. Some of you may be familiar with PuTTY. That's another way, but it's a little bit more complicated because you have to install PuTTY, and you also probably want to install another program called Xming, which helps you do visual connections. But MobileXterm contains everything, so it's much easier to use. I'll go into detail about how to do that later. On a Mac, you can get away with not installing anything, but it's recommended that you install something called Xquartz, which will help you do graphical interactions. So for MobileXterm, you can Google for it and you can connect to the website, and there are actually 2 versions that you can have. There's the portable edition and the installer editions. You can, if it's your own computer, you can use the installer edition. But if it's in a public computer that you don't have root access, you can use the portable edition. So once you download that, you'll get something like this, and you can just start the program, the .exe, the MobileXterm personal -8.6 exe. Actually, this is an older slide, so the version number's probably changed by now. Then you get a window like this, and then you can just click on the Start Local Terminal, and that will basically open up a terminal on your local machine, like this. And once you're there, you can connect to Cedar by typing in SSH and then your username at cedar.computecanada.ca, and then it will ask you for your password. So, as I said, with MobileX terms, everything's included. So if you want to transfer files, you can just drag and drop into the side window from your computer, and vice versa, to transfer files. Now, if you're on a Mac or Linux machine, it's basically works the same way. So you open up on a Mac, you would open up a terminal window. On a Linux, you probably have similar applications, and then you can just type SSH. Here I added a -y, and that helps you again with graphical applications. On MobileX term, that was sort of automatic, so you didn't have to type in the -y. This is a capital Y, by the way. For all the Compute Canada systems work in Unix systems, and so and Unix commands are case sensitive, so there's a difference between a capital Y and a little y. So otherwise, it looks the same, and you can log in this way. Can everybody try to log in now? Yes, I'll just get out of here, and this way I can see what's going on with people. So if you have any questions, problems, just speak up or type in the chat window. Is it a big issue if I don't include the -y argument? No, it's not. If you're comfortable with working in a command line only mode, we'll get into editing later. And if you're not familiar with the standard Unix editors, then it will be easier to use a graphical editor, in which case you would need a -y. Yes, you could just close. So to close the terminal, it will be either exit or Control-D will allow you to exit. What's the difference between -y and -x? I'm not sure exactly what the differences are. I use -y because it works better on a Mac. -x doesn't always work. So everybody okay with that? If some people aren't ready to go on, if they're still trying to install MobileX term or having trouble with logins, please speak up or type in a message. Okay, so I assume we're okay. Now, transferring files between your computer and Cedar on a Mac or Linux, you can use a command called scp. So you would type scp, your file name, then your Compute Canada ID at Cedar. Oops, that's a mistake. That should be Cedar. Let me just correct that while I can remember. So cedar.computecanada.ca followed by a colon, and that's very important. If you don't put that colon in, it will just copy that file to this big long name. If you don't like commands, there is a graphical program that you can use to transfer files, which is called FileZilla. That exists on Macs and Linux and even Windows. You can do that. On Windows, as I said, with Mobile Xterm, you have the transfer capabilities included, so you can just drag and drop into the side window. There's another program called WinSCP, which is common as well. So that will be the way you would transfer files, which yes, most of you probably will need to do before you can start work on these machines. Okay, so I'm just going to ask you to log in at this point, I guess. So once you're logged in, you're on this login node, and interactive use should be limited. As I said, these systems are meant for batch use, so things you do on the login node should be limited to compiling, testing, debugging. Not more than 1 hour or 2 cores. If you need longer interactive use, there is what's called an interactive batch in a command called salloc, which allows you to do that. I will explain that a little later. Okay, so the first thing I want you guys to do is to copy a file from my directory to your directory. So cp is the copy command for Unix. That little squiggle in front of Masao says that this is my home directory. So by typing squiggle Masao, you're going to refer to my home directory. And there's a file called workshop sept 2017.tar.gz. And this is what's called a tar archive. It's a way of archiving a directory in Unix. So this file contains a directory that you will be installing basically into your directory. Now, the copy command, it ends with a little dot at the end. That's very important. So there's a space after the GZ and then a little dot. And that allows you to copy to your current directory, wherever you are. So I want you to do the copy, and once you've copied, you can untar it. So by doing the next command, which is tar -xf, space, and then the name of the file that you just copied. And that should create a directory called workshop sept 2017, and you can go into that directory with a change directory command, cd. Okay, so I want everybody to do that. I'll wait for everybody's to be done.
Masao, there's 2 questions.
Yeah, well, the question about ANSYS, it's a little off topic, but we are setting up a system for Fluent. I guess it's part of ANSYS. I don't know if HFSS is included. I think there are licenses with ANSYS. We have a setup so that if you have your own license, we can run ANSYS software, at least Fluent. I don't know about HFSS on the Cedar. So we do have a bring your own license model. In the worst case, you can always install it yourself into your own directory. I will mention a little bit about Globus at the end, not a lot in detail, because that is the, if you have a lot of data to transfer, Globus is a much better way than the SCP command or the using MOBEX term. Yes, so Naomi, you have to put a space and a dot after the GZ in the copy command. There's a little dot, a period. Is everybody okay? I'll go on. Okay. In the Compute Canada system, as it was with WestGrid, your environment for running programs is controlled by modules. You can now type module avail, and it will give you all, not quite all, it will give you software that is available. The difference between the new systems and the systems we've had in WestGrid, and I'm not sure about elsewhere, is that this is organized in a hierarchical fashion. And according to compiler, or the use of MPI, or the use of CUDA. So when you just type module avail, it will show you all the software that is compiled with the Intel compiler. When we're installing software into the new systems, we try to install it with different compilers, but some software will only install with one of the compilers. So when you do module avail, you may not see the software that you're looking for. Okay, so, well, here's a picture of what you might get. So these are, again, subdivided according to whether it uses MPI or not. But if you don't find what you're looking for, what you can do is the module spider command. For example, you may have noticed or not noticed, there is no blast plus when you do the module avail command. And to find it, you would have to type module spider blast plus. And then you'll get a message saying that you'll need to load the following modules. Now, the first one, next packages, you don't need to worry about. That's always there. But the second one, GCC, tells you that this program was only available through the GCC compiler. So in order to load it, you have to do module load GCC blast plus. If you want to see the list, well, once you do that, you get into the set of packages which are compiled with GCC. So if you do module avail again, you'll see a slightly different list. You can also check our website, which has the complete list of available software. So, and it's written here. And it sort of looks like this. Go there. And you can search for software there. I should note that the software that's listed here or the software that you find through Module Avail are basically scientific software and not really basic Unix software. So there's some software which is more Unix software that's always available that you may not see on this list. And if you can't find it, you can always request installation. But anyways, so there are other options like installing your own. And you can always install software in your home directory. So I put a link there for some instructions. However, some software are distributed in a binary form, and because we have a very special software environment on the new systems, they may not work right away. So you may have to make changes to them. The instructions are given in this link that I've given. And in particular, for installing your own, we've decided that we will not be installing a lot of Python packages as part of the regular system available through the modules. There is, however, a Python SciPy stack, which allows you to load the SciPy packages, and the MPI for PY as well. But other ones, what we've done is to compile packages as Python wheels, which are sort of like pre-compiled packages, and then you'll be able to load them into your own environment. And instructions for doing that are given in this link here. And similarly for R, we've only basically compiled some basic ones, and then there's a special module for a bioconductor, which has a rather large number of packages. But other than that, you should be installing R packages in your own space. And similarly for Perl. And the instructions are given at those links. You may have a little hard time finding some of these links. I find it on the docs.computecanada.ca wiki page that it's often easiest to just do a search. You will even find pages like R, like typing R into the search. So, but if you're not, other than these Python, R, and Perl, you can also request installation of software. We may not get to it right away. It may take a week or two to install, but you can send a request to us. Okay, so we're just going to go through some basic exercises for what I think should be things you should need to know for working with programs, running programs. So we're just going to start with basic compilation. So we have the Intel compiler installed on all systems. The C compiler is called ICC, and the Fortran compiler is called iFort. And in the directory where you are, there's a program called hello.c or hello.f90. And I want you to just pick either C or Fortran and try compiling it. So you would just type, for example, ICC-O hello space hello.c. And that should create a file called hello, which you can run with a /hello. Now you need the / because you need to tell the system where to find that file, and a / means it's in the current directory. Okay, so it's an exercise for you to do. So the difference between ICC and iFort is the language. So ICC is a C language compiler, and the hello.c is a C language code. And similarly, iFort is a Fortran compiler, and hello.f90 is written in Fortran. Okay, I hope everybody got that. So one of the places to get documentation in Unix is what's called man pages. Man for manual, I guess. So you can type man space ICC, and it will give you the documentation for the C compiler, the Intel C compiler. The way these pages work is similar to a command called more or less, if you know about them. So you type the spacebar to get another page. You can do slash and then put a search term to search for a particular term. And then you just type Q to quit. And the problem with the Unix man system is that you have to know the name of the command in order to get information about it. And so one way to know what the command might be called is to do a man minus K and then whatever topic. So if you type, I don't know, man minus K copy, you may get all the software that's related to copying. Okay, so now we want to start editing some files. This is where the -y will come in. So most of you probably don't have experience with Unix non-graphical editors, which are the most popular ones are called VI and Emacs. VI is very hard to use, but I use it because it's faster and I'm used to using it. Other people prefer something called Emacs. But for beginners, I would recommend a graphical editor. So there's one called Nedit or gedit on a lot of Unix systems. It is also possible to edit through one of the file transfer programs called WinSCP, and I do not recommend this because what you end up doing actually is editing on your PC and then transferring the files back and forth. So not only is it's a sort of waste of bandwidth, but also moving files from a PC to Linux can cause problems. Okay, so we're going to be making a batch script and you will need to edit a file. So you can open up an edit session, for example, by just typing an edit, or you can create a name at the same time. So an edit, you can call it job.slm. I tend to like SLM because that sort of stands for Slurm. In Unix, the extensions don't mean anything. They're just for your convenience, unlike in Windows. So you can call it anything else you want. You can call it .sh, whatever. But create a file, type these lines in, except you will have to, I have to back up a little bit, because you probably don't know what to fill in the second line. Okay, let me just check something. On Compute Canada systems, your account is associated with an account name, basically, well, or allocation. Most likely, your default account name is def dash your username, and I think that should work. And so let me just go through some of these lines. The first line, the bin bash just tells you what kind of script this is, and in most cases, people will be working in what's called a bash script shell. So you can just leave that as it is. The next lines, starting with sbatch, are all commands to the batch scheduling system, asking for resources. The first one is only needed for today. We made a reservation for some couple of nodes so that we can work in batch without waiting for jobs to run. So this line is needed only today. Reservations equals masao _10. So the next line, minus account equals def dash your account name, should get you to your allocation, which is the default one. The end task equals 1 is asking that I have one processor job to run. Mem per CPU is asking for 2,000 megabytes of memory for that. A time limit of 5 minutes. Asking for mail type equals all. That means you'll get mail when it starts, when it ends, when it aborts. And then your email address. And then you'll be typing in your command, which is /hello. Okay, so I want everybody to type all this into your editor. Gives you segmentation fault. Oh, great. Okay. Yeah, so Camille put in a command to give you your accounting group name. Now the segmentation fault, I hope. This is not going to be an issue. Okay, it works for me. Are other people having segmentation fault errors? Now, Fatima, you can't. Let's see. Well, we're not ready to submit yet, and just want everybody to type this in for the moment. We're not ready yet, Camille. Segmentation fault. Can you type ulimit minus a and paste in what you get? Ulimit space minus a. Lowercase a, yes. Okay. Oh, uh, you should be working on Cedar to do an edit. It won't help to create this file on your computer. So you need to type and edit in the terminal window of your Cedar session. Well, if you're still getting segmentation fault, can you try nano? So we will wait a couple more minutes before going on, make sure that everybody's typed in a batch job. Okay, so the accounting group is not named after your username, but your boss. I guess I'm different because I'm my own boss. So everybody okay with editing file? Okay. So, as some of you may have noticed on the side, the way to submit a job is called sbatch. So you would type sbatch space and whatever the name you gave to your job. And here I'd use job-cedar.slm. And it should give you a line saying submitted batch job and some number, which is your batch job number. You can see what your job is doing with the sq command. So if I type sq -u Masao, I get all the jobs that I have lined up. And here, if it's waiting to run, in the 1, 2, 3, 4, 5, fifth column, it should say it's the ST column, which is the state, I guess. When it says PD, it means pending, so it's waiting. And at some point later, when it starts running, that should change to R. Okay, so everybody submit their jobs. And you can try the SQ command. Once the job finishes, then later on, you won't get any output or a line showing any jobs at all. And hopefully, because we made a reservation, and if you put the reservation line in your batch script, it should run right away. So once it runs, you should get an error file called slurm-the job number.out, and it should contain the same output as you had when you were running interactively, which is just the output of the Hello World program. Some of the common errors why a job might fail is it ran out of load time or it ran out of memory. If your batch script is in a DOS format, and this is what can sometimes happen when you're transferring files from a Windows system, and that's why it's better to edit your files on Cedar itself. And that creates no end-of-line character at the end of the file. That happens when you transfer files from a Windows system sometimes. In this case, you can just add another blank line at the end, and that can get over the problem. But it is best just to edit on Cedar and avoid such problems altogether. Okay, so that was a very simple program. I want to work with something a little bit more complex, if you want to call it. So the Hello World program didn't take any input. It just had an output. You just run it, and it ran. So this is a program that requires input from you. So you can compile it with ICC-O pi.c. And you can try running it interactively. And it will ask you for input. The program basically calculates pi, and you give it the number of digits you want calculated. Just play around with that a little bit. So here's a program that requires an interactive input, but we want to run in a batch environment. So how do we do that? There are a couple of ways. You can create a file for your input. So one way is to create a file here. I just call it pi.in, and you would put what you would normally type into that file. And there are a couple of Unix ways of putting in an input file. So the left pointing arrow is telling the system to take my standard input from a file called pi.in. And similarly, when you run the program, you would normally put output to the screen, but you can also redirect that to a file by using the right pointing arrow bracket, I guess. To here, I called it pi.out. And so this way you can run this program in a batch without doing any interactions because you've already put in your input into a file. There's an alternative way of dealing with such programs without using an input file, which may be convenient. You can put everything in your batch file this way. And this makes use of the double left-pointing bracket, followed by a set of characters, which is arbitrary. In this case, I called it EOF, or end of file, -pi. And then I still have the right pointing bracket for the output file. And then I would type in the characters that I want, the input that I want. So I have 100, 1000. I guess it's not the number of characters, it's how many boxes it makes for calculating pi. And then I have a 0 for the end of the calculation, and then followed by EOF-pi. And so in this case, the input comes from what follows until the EOF-pi is reached. But as I said, the characters that you use here are arbitrary. You could call it anything you want, A, B, C, D, E, F. So that's another way of making an interactive program into a batch system. Okay, I just wanted to touch on parallel programming a little bit because we'll be running some parallel programs later on. One of the ways you can parallelize a program is through something called MPI, which I think stands for Message Passing Interface. And these programs are written in a special way, and they require a special way to compile it. Again, I've given an example for C and Fortran. So the C MPI compiler is called MPI-CC, and the Fortran one is called MPI F90, and you can just choose one of these, try compiling. The way you compile looks the same. It's, you have -O and then followed by the name of the executable that you want to create, and the name of the source code file. To run it interactively, you have to do a little trick first. We've been tightening up on resource limits for your interactive use because we've been getting a lot of interactive users that abuse the system and use up all the resources of the login node and even crash the system. So we've been putting in limits, and to run this program, you have to type in ulimit -L. So this is a lowercase l. It's not an I. It's not a 1. 2097152. It just sets one of the limits to be higher than what you get by default. And to run these MPI programs, you can use a command called MPI exec. -NP is a flag for how many processes you want to run. So here I give 2. I want 2 processes run. And the hello MPI program. And it will work like the hello program you've run before, but it will do it twice. So just give this a try. Here, so I've used MPI exec, but in a batch environment, more often you would use a special one for this batch scheduler called srun. But you can still keep using MPI exec. Apparently, srun runs a little bit faster. But here we're running interactively, and we just stick with MPI exec. Slide 26. No, we're still back in. Oh, I forgot to say, if you want the slides, they are also in my home directory, so you can download it to your computer from there as well. It's called using ComputeCanada.pdf. So every word is capitalized at the first. So it's in my home directory. So squiggle masal, you can download that one, or you can go to the WestGrid website and to the page about this workshop, and then there's a link to the PDF as well. Okay, I hope everybody had a chance to play with that a little bit. So I talked about an interactive batch job you can do. So this is useful sometimes if you do need to run interactively for a long time. It works like a batch job, except that you'll be logged into a node instead of submitting a job to it. There's another error. So it looks sort of the same sort of resource requests, except now everything is on one line. So you can try typing this in. And perhaps not. Why don't I change that to 1 as well? Because we have 2 nodes with. No, maybe that should work. Okay. So you can type in this line with SLOC. You have to put in your account name, but everything else should be the same. And hopefully there's enough room for everybody to get onto a node. And it allows you to have 2 tasks. So you can, what you can do, so you may notice when you do get into a node that it automatically puts you into the directory you were in before. In fact, with this batch scheduler called Slurm that we use, the default behavior when you submit a batch job, or if you do SLOC to do an interactive batch job, to maintain the environment that you had before you did that. So if you had loaded modules in before, that would also be still loaded when you log into the compute node. But I think it's always safer to load the modules into a batch job, even if you're trying to maintain the same environment. So anyways, everybody try that. See if they can get in. Notice that there's no batch script involved here. And on a real system, you may have to wait a long time before you can get a machine. Once you're in, try typing in srun /hello-npi without giving the number of cores. If you had asked for 2 tasks, you should get 2 hellos back. You can also type npi exec /hello-npi. Fatima, can you type in or paste in exactly what you typed in? Yeah, the account name is probably wrong. It's probably Jeff something. We had a command before. Suri, if your Python code is not written to be in parallel, it doesn't help to run with npi exec. It will just spawn just parallel instances of the same thing. So you have to, there's something called npi for pi, which you can use to parallelize Python code using npi. But if you haven't done any parallelization to the code, it doesn't help to use npi exec. salloc, what does it stand for? S for slurm and alloc for allocate, I suppose. The batch system we're using is called slurm. And don't ask me what that stands for. Okay, I hope everybody had time to play with it. Just when you're done, just exit by typing exit or Control D. Because we'll need all the nodes again for further exercises. Now, probably a lot of you who are going to be using Cedar or Graham will be running parallel programs, either written by yourself or by using systems available from elsewhere. And one of the important things when you're running parallel programs is that you have to do some benchmarking to know how many cores you should be using, because not all parallel programs work in parallel. And so I want to talk a little bit about timing your programs. And when you do timing experiments, it has to be reproducible. That means without having other users interfering with your runs. And you can use the time command and look at what we're used to calling wall time, which is basically the time, the real time on the clock on the wall, I guess, where it comes from. So for running parallel benchmarks, you want to time the real time by using different numbers of processors. And you need to establish the parallel efficiency, so to know how many cores you should be using to get the maximum throughput, basically. Okay, so we have a benchmarking exercise. I have a program called sample1. This one is just written in Fortran. And you need to compile it with the MPI compiler. So just type exactly as it says, MPI F90 space minus O space sample1 space sample1.f90 space minus fixed space minus O0. So don't confuse the two circles. The first one is the capital O, and the second one is the number 0. And once you've done that, I have a batch script. Wait a minute. That's a mistake as well. Yes. Just click that. Oops. Let's go back to that. Okay. Yeah, so the script is called script1.slm. And you can submit it with sbatch. And well, if you're curious, you can look inside, but what this job does is run the program 5 times, changing the number of processors from 1 to 12. It will output a file called out.time. And if you type the command grep space real space out.time, you get the time for the different ones. And then you can try plotting that with Wolfram Alpha, which I've used here, and it allows you to make a nice plot. So you have to type in these plot commands. You have to replace the T1, T2, T4, T8, T16 with the values that you get, and you'll see you get a different plot. So you should see a plot something like that. We'll just go back here. So one is the actual time, and the other one is the speed up. So they're in comparison to the time it took to run with one processor. Okay. So can you compile a program, submit it, and then plot the time? No, in this case, there's only one dash in the options. Yeah, some Unix programs often use double dash to have options which are words and they have a single dash for options which are basically abbreviations and use only one letter. With in this case, it's just a single. Maybe the double does work. I didn't try. How do we submit? Same as always, sbatch script1.slm. but that you have to do that after you've compiled. Okay, what kind of compilation errors do you get? Ah, that was the error. Okay. I don't know about getting output from the SLOC. I haven't tried it. You can try it and see if it works. You can try setting a -0. Doesn't work. Okay. Well, you can always copy and paste your Windows session. That's basically what it amounts to. It doesn't actually make sense because you're working interactively and whatever it prints to the screen goes to a file. Instead, you won't know what to type. Well, if you have so many lines of output, I don't know if it makes sense to do it interactively. Yes, you can't use mine. Oh, yes, you'll have to change that. Sorry. So you'll have to edit the file and put in your account name. Sorry. So that should take quite a bit of time. So if you want to stretch your legs as well, now is the time. Did I not change the files? Okay, Rhiannon, if you're using prox equals 32, okay, I guess this looks like a Hungary thing. Well, there are 32 cores in a node, so you would ask for nodes equals 1, tasks, I guess, n tasks per node equals 32, and then I think, what's it called? I guess I should. By the way, there is a web page on the docs.computecanada.ca called Running Jobs, and that will tell you some of the basic parameters. So the one you want is So the MEMS per CPU, but you wouldn't put 8190 because that was for Hangabi. Depends on how much memory you need in total. Notice another mistake here. Should have been 16. I noticed there's still some people that are running interactively, I guess, because they asked for 2 CPUs. LJK003, Tomsky, F. Mershop. Has anybody managed to run this already? I don't notice any 16 core jobs. Maybe we'll just go on. So if you ran this successfully and got outputs, you would get something like this. So the one on the left shows the actual time. So the time it takes is decreasing, which is good for parallel programs as you use more processors. On the right, you see the speed up. Now, the ideal speed up should be a straight line. And so you can see that this is not such a hot parallel program because it, beyond 8 cores, it actually doesn't improve it very much. So this is the kind of thing that you need to look at when you want to run a parallel program. Most programs will perform better than this, but almost any program will have a similar shape as, if you go far enough in the number of processors. And so you need to look at what would be an optimal point in terms of number of cores that you're using. And in addition, the more cores that you ask for, the time it takes before your job starts will tend to get longer because you're asking for more resources, and so more resources have to become free, and so that usually takes more time. So there's a trade-off between speed up that you get by using more processors and the waiting time. Okay, another way to get speed up is just by optimizing your code, which you should do in any event. But one of the simplest ways to optimize is just use the compiler to optimize your code. The default optimization level is called O2, so capital O2. But there are higher optimizations like -O3 and also specialized hardware accelerations, which is indicated by this AX core AVX2. To get an idea of how much difference a compiler optimization can make, I have the following exercise. So compile the program called sample2.c. For example, you can do ICC-O sample2, sample2.c -O1. So that compiles with the optimization level 1. Now you can time it with the command time /sample2, but you can try that interactively, but also try it using an interactive batch job because you'll probably see a difference. And as I said, you should run benchmarking under a condition where other people won't interfere with you. And when you submit a batch job, you are allocated, a part of the computer which corresponds to the resources that you ask for. So if you ask for 1 core, you're guaranteed to have that 1 core to yourself. Now you may still have interference because it doesn't preclude other things like networking or disk I/O. So just give it a try. Try some different optimizations. In particular, though, what this program does, it doesn't really matter, but what it does at the end, it prints a sum. And what you see when you run the different optimizations is that that number can change. So what the compiler does when you get to more aggressive optimization levels is it starts to sort of cheat as far as floating point operations are concerned to make things run faster. And so now the difference is very little, but there is a slight difference. And if such differences are important to your results, then you need to pay attention to those floating point precisions. And the final optimization here I have, which has the flag FP model precise, makes sure that the floating point operations are done according to a set standard. So just try running some of these optimization levels, different levels, interactively on your login node and also by running SLOC. This is not an MPI program, so just ./sample2. Okay, we'll go on. So here's another way to speed up programs by using precompiled, optimized math libraries. The Intel compiler comes with something called the math kernel library, which contains various routines for doing linear algebra, FFT, and things like that. So if your code uses such routines, you can use the math kernel library to speed things up. And for the Intel compiler, you can add a flag -mkl equals sequential, and that will give you the sequential version, which probably is the best to use. But otherwise, the MKL will try to use all the cores on your machine, which may be too many for the job that you're doing. Okay, little explanation about file systems, which is a little bit complicated and confusing. When you log in, you're in what's called the home directory. And on Cedar, there's a rather small quota, so you shouldn't keep a lot of things in your home directory. The main storage should be in what's called the project space. And in your home directory, there are two links. One is called project, I guess I should put that as a, because it's with a small p. And so there's two. One is called project, and the other one is called projects with an S. And the project link gives you your default project. And whereas if you go to the projects with an S, it will have links to projects, other projects that you may be involved with. And then there's the scratch directory, which is also a symbolic link. And that should be used for running jobs because that space can be cleaned up from time to time. I don't think there's a regular schedule, but I think probably when it starts to fill up, that will be cleaned up. And then as I said, there are quotas for these, and to get the quotas, we made a script called disk usage _report, and it will give you the quotas. Now, in the project space, the quota is according to your group. And there was some confusion at the beginning where things changed, and some people ended up with files in those projects directory which didn't belong to the group but to the user, and so you may if you see quota exceeded when you seem to have lots of space using the disk usage report, that may be the problem. Anyways, if you're having any trouble with quotas when you think that you shouldn't be, just send us an email at support@computecanada.ca. There's more description about these also in our docs.computecanada.ca because these directories, the project directories especially, are meant to be shared within the group. So there are special commands that you will have to use to make sure that other people in your group can see the files that you have. Or if you don't want the other people in your group to see the files, you can also make sure that that's the case. So for moving data in Compute Canada, especially if you have large amounts of data, Globus is the way to do it. The link to the description is given here. It's a web-based transfer method. So you would connect to the web and basically give commands. You want such files or directories move from this site to another site. And the big advantage is that it's fault tolerant. So if there are any network problems or one of the servers has a problem, it will try again later. And you can also transfer to your desktop by installing a Globus application on your desktop machine. And so, again, if you have a large amount of data to transfer, this is the way to do it. It's a little bit more involved than doing SCP. So, I would use SCP for small files. But if you have a large amount of data to transfer, this is much faster. It's fault tolerant. And there's a little bit tricky when you're doing the transfer. You need to connect to the Globus site first, and that you have to do using the Compute Canada login, and using your Compute Canada ID, which may or may not be the same as your WestGrid one, and your password, which may or may not be the same as your WestGrid one. So, and once you connect, if you want to transfer from a WestGrid site, there you have to log in using your WestGrid credentials. So if these two sets aren't the same in your case, in my case, my username is different on the two machines. My password is different, so I have to keep straight which one I'm using. that's sort of the end of my workshop today. I have some advertisement for future training sessions coming up. So October 3rd, there's data visualization. October 5th, parallel programming for shared memory machines. So that would be that would most likely be OpenMP as opposed to the MPI that we looked at today. 24th to the 26th, that's the scheduling talk. That's 3-day talk by Camille. So if you want to know everything you wanted to know about scheduling and how to get your jobs run faster, that's the one to come to. November 1st, Introduction to Molecular Dynamics, and November 21st, Containerization with Singularity. And please note that all these times are given in different time zones. Most of them in PDT, but one of them in MDT and one of them in PST. So make sure you have the correct local time. And finally, getting help. So as I said, a lot of documentation is available on docs.computecanada.ca, and use the search bar if you don't see it in the menus or the links. That usually gets you somewhere. But if you don't know, if you can't find the answers, you can always send an email to support@computecanada.ca. But make sure you specify, especially if it's about a job that you're trying to run, what your user ID is, which system, whether it's Cedar or Graham or Arbutus, the cloud, your job ID, error messages, and the script location. If you want us to look at your files in your directories, you do have to go to your Compute Canada website and give us consent, or give us consent in the email that we can look at your files.